Okay, so this is our little robot cell, one of them. We are creating a lid picking or bin picking application. I'll talk to you about that in a sec. And then on this side we have our the food application, where we're going to have a robot that's going to be doing we can have a robot that's going to be doing taking out ingredients from a freezer storage. In here we're going to build a custom setup for ingredient management, frozen, chilled, whatever. And then we're going to have a robotic cooking machine in here that the robot can take the ingredients and put them into the machine, cook the food, take them out, and then give it to the customer. We also have a baking application that we are testing on. The next thing, this is a little setup we're doing for another client who has a local factory. They do supplement nutritional tablet products, like pills and tablets, and they have a bottle filling application that currently done by human labor, because you can automate it, but the machines that's currently available there for 200,000-300,000 long large bottle filling lines. You do the same product several 100,000 times, then it's worthwhile investing, because you need a large space to put all the lid sorting, bottle sorting, filling lines, conveyor belts, the whole setup. What we're trying to do is to transform that system into a much more micro manufacturing setup, where right now there are lots of smaller businesses, small to medium businesses. They just don't have that large volume of manufacturing, but they have several thousands of batches that they need to do. So they're not big enough to invest into a large space, large manufacturing machinery, but they have a small to medium size production, which then they are currently doing it by having loads of manual labor, picking up a bottle from a bag, putting it under the filling machine, get it filled, then get a cap, a lid from a bin, and then screw it in, put it into the conveyor belt. So that's quite a very repetitive task, and the reason why machines can't mimic that easily is the fact that you're looking at a pile of different objects and sizes, and to accurately go and pick up from a pile is very difficult, because this is a pretty much a 6-dimensional problem. You've got your X, Y and Z, which is the depth, plus the rotations, etc. So this is one of the hardest applications in robotics when it comes to 6-dimensional work with the vision. So a lot of people, what they do, robotic and automation companies, they just have a single plane conveyor belt or a single plane, and you're going to have objects coming one by one on that conveyor belt at a fixed height. So all you need to do from the vision is just to locate where the object is, and then give the coordinates to the robot to go and pick it up. So that's a much easier way of doing it. But what we want to take it to the next level, where to make the process as simple as possible, a staff can bring a big tray of lids, shove it into the robot cell, and robot will press the button and it will just work it from there. It would analyze the video footage. So we have, for example, quite expensive depth vision RGB cameras mounted, and it will go up there, look at the scene, work out where the bottles are. At the same time, it works out where the lid's located in the X and Y scene, plus it would locate the distance from its position into the each lid. So it knows when you look at that lid or this lid how far it is from the robot's tool center point, and then it will get the coordinates, calculate it. So there's a lot of back-end software going on underneath. There's a machine that runs all the software, the vision stack and everything. Camera will look at it, it will give that information to the computer run it through several layers of application. It would just kinematics and all of that in the control boxes, and then give the coordinates to robot to go into this X, Y, Z and this rotation to go and pick it up. So that's a bit. So we're running it constantly throughout the whole day to test this, and these are our little equipment setup we have. Pretty much most of the enclosures, settings, everything's 3D printed and designed by us, especially this mechanism in here where we have a folding suction probe that works with the pneumatics. And the way we done it is when it's doing the bottle picking using this gripper, it would fold the suction probe so they don't interfere, but when it's doing the lid picking, it will retract the suction probe and then pick up the bottle lids and then bring them up. So yeah, we are the bottle lids are the difficult part of the task, so we are just running that a long duration to test everything. We then have a bunch of bottles like this, about 200 of them. The plan is that the bottle's going to come in a big casing. Staff will come and place the casing. Robert will look at the scene, pick up the bottle from its neck, and then it will place it, grab it from the side, go into the filling machine, get it filled. Then it will go and grab a lid, place it on the top loosely, and then it will go into that machine there. So that's a bottle capping machine that we have, and then it will get the lid screwed on, and then that filled bottle with the lid will be placed on the conveyor belt, and then it will just keep repeating that process. So yeah, that's what we are trying to achieve. So let's see how things go, and I'll post more videos when we have more progress.